To find the resistivity of the material of the wire, apparatus required, we need rheostat, we need battery eliminator, ammeter, voltmeter, a wire whose resistivity is unknown, and a plug key. The purpose of using battery eliminator is to convert 220 volts power supply, whatever we are using, domestic power supply is 220 volts. That 220 volts has to be converted to 2 volts, 4 volts, 6 volts, whatever according to our convenient. We can just turn the knob and then we can use it. So all the experimentation, whatever we are doing, we will use a battery eliminator in order to convert 220 volt to lower volt, so that it will not make any harm. So we are using the wire whose length is known and the radius of the wire is known, but we are not aware of resistance of the wire. So by this experiment, according to Ohm's law, we can find out the resistance if we know current and then voltage. So by the formula V is equals to I into R is equals to V by I. So by this formula we can find out what is R value, then we will find out what is the resistivity by using the formula rho is equals to pi R square R divided by L, where rho is the resistivity, R square is radius of the wire, radius of this wire, R is the resistance which we will calculate using this experiment and making use of Ohm's law. L is length of the wire, length of this wire. So the length observation, radius of the experimental wire R, here I have considered, and using screw gauge I have been calculated the radius of this wire is 0.09 centimeter and length is 50 centimeter. No need to worry, the radius of the wire and the length of the wire will be given by your teacher itself. So now we will begin with the experimental setup. In order to set up a circuit diagram, we need to make use of the circuit which is given in the lab manual. So lab manual, according to this circuit, it says positive terminal of the battery eliminator is connected to positive of the ammeter. So positive terminal of battery eliminator is this brown or red color, black one is negative terminal, you can observe here. So from here positive terminal of battery eliminator has to be connected to positive terminal of ammeter. So A represents ammeter here. So from here to here we are connecting now. Yes, this connection is done. From positive terminal of battery eliminator I have connected to positive terminal of ammeter. So now from negative terminal of ammeter I have two connections. One is connected to the wire which we have considered, and the same terminal is connected to positive of voltmeter. So that means here at the negative of ammeter I need to consider two wires. One goes to the wire and other goes to the voltmeter. Yes, you can observe here negative terminal of ammeter I have considered two wires. One is connected from negative terminal of ammeter to positive of voltmeter. The same negative terminal of ammeter is connected to one end of the wire which we have been considered. This is so. Next, the negative terminal of voltmeter is connected to the another side of the wire which we have been taken. So from that side again it has been connected to topper end of the rheostat. Means from this negative term of the voltmeter, negative terminal of the voltmeter, I need to connect to another terminal of the wire. From this wire again we need to connect to top end of the rheostat. So this is the top end of rheostat and these are the bottom ends of the rheostat. Yes. So negative terminal of the voltmeter is connected to another end of the wire we have considered. From the same another end of the wire I have connected to rheostat top end. So from now, so the bottom end of the rheostat is connected to key one end, and another end of the key must be connected to battery eliminator negative. So that is the lower end of the rheostat. This is the lower end of the rheostat. Lower end of the rheostat must be connected to one end of the key. So this is one end of the key, this one, and another end of the key is connected to battery eliminator negative. Yes, I have connected the bottom end of rheostat to one end of the key and another end of the key. You can observe the another end of the key. See, I have connected here. Another end of the key must be connected to the battery eliminator negative. So this is about a simple circuit for the experiment number 1 to find the resistivity of the wire. So from positive of the battery, it has connected to positive of the ammeter. Negative of the ammeter is connected to positive of voltmeter, and the same end is connected to one side of the wire which we have considered. Now negative of voltmeter is connected to another side of the wire, and from same another side of the wire it is connected to top end of the rheostat. So now bottom end of the rheostat is connected to one end of the key and another end of the key is connected to battery eliminator negative. So this becomes a complete circuit and circuit for the first experiment. So now we shall on the circuit, that is battery eliminator we on. So then we need to just move the knob of the rheostat. See, this is a knob of rheostat which is used to vary the resistance. Yes, so this is simple. We will just move it. So you can observe when I am moving, see, you can see the deflection. See, both voltmeter and ammeter are varying. Both voltmeter and ammeter will vary. Yes, you can observe now. Yes, both are varying. So now we can see the readings. It is at 0. Yes, we can observe here. Voltmeter reading is 0.5, whereas ammeter reading is 0.25. 0.5 is voltmeter reading, 0.25 is ammeter reading. Same thing I will note down here. 0.25 ammeter reading, 0.5 voltmeter reading. Using Ohm's law, V is equals to IR. I can calculate R is equals to V by I. So R is equals to V is 0.5 divided by I is 0.25. So which is nothing but 2. So again you will just move the knob of a rheostat and you will take the readings for different values. So you will take 3 trials and you will calculate R value and you will calculate what is a mean R. So mean R you will calculate, and for calculation you use a formula rho is equals to pi R square R by L. So R square value we know, pi into what is R square value, 0.09 into 10 power minus 2 centimeter it is square into R value. Suppose let me consider 2 itself. So 2 divided by 50 centimeter. 50 into 10 power minus 2 centimeter I am converting into meter. So now we will do the calculation and keep the value of resistivity in ohm meter. So this is about the first experiment, and result we will be noting down in ohm meter. Whatever we get here answer, same thing we will note down here in terms of ohm meter.